All right, here we're going to be talking about absolute value. All right, so the definition of absolute value. Well, first of all, the notation for absolute value is two vertical lines with some expression in between. All right, so in this case, the two vertical lines with the a in between them means the absolute value of a. Right, so the definition for absolute value is the absolute value of a equals, and then there's two different things depending on what a is or what type of number or quantity a is. Right, so this is what we refer to as a piecewise defined definition. Right, the absolute value of a is equal to a if a is greater than or equal to 0. So if a is a positive number or 0, the absolute value of a just equals the same number. Right, if a is less than 0, then the absolute value of a equals negative a. Right, the opposite of a. Right, so again, it's what we call a piecewise defined function, where it's defined in two separate pieces depending on what number you have inside that absolute value. Right, that determines which one of the two definitions you're going to use. Right, and for absolute value, it's all about, is that number basically positive or negative? If it's a positive number, the absolute value is just the same number. If it's a negative number, less than 0, then it's the opposite of that number. It's the negative of that negative number, which makes it a positive number. Right? Another way to think about the definition of the absolute value, graphically speaking, the absolute value is the distance of the number from 0 on the number line. All right, so if I want to talk about the absolute value of -3, well, -3 is down here 3 units away from 0. So the absolute value of -3 equals 3. Right? We wouldn't say that the distance of -3 from 0 is -3 because we don't measure distances as negative numbers. Right? You wouldn't say, oh, I'm standing -10 feet away from you, or you're playing baseball or something. Oh, we hit the ball -400 feet. That doesn't make any sense. We always measure distance as positive numbers. So the absolute value of -3, that's positive 3 units away from 0. Right? The absolute value of 5, well, 5 is 1, 2, 3, 4, 5 units away from 0. So the absolute value of 5 is just 5. Right? That's why this definition is what it is. Right? If a is greater than 0, like 5 is greater than 0, well, then the absolute value just equals that same number. The absolute value of 5 is 5, because 5 is a distance of 5 from 0. Right? So it's just the same number that you already have. If a is less than 0, if a is a negative number like -3, well, then the absolute value is the negative of that. Right? Negative of -3 is positive 3. Right? So if the number you're taking the absolute value of is less than 0, the absolute value just turns it into the positive of that number. Right? It turns -3 into positive 3. All right, so that's the definition of absolute value. I'm going to pause this and then put up some of the properties of absolute value that we'll talk about, and then we'll also do a couple examples here. All right, we've got here some properties of absolute value. The first one, the absolute value of a is greater than or equal to 0. Right? When you take the absolute value of a quantity, it's never going to give you a negative number. It's never going to give you something less than 0. It's always going to give you either 0 or some positive number. All right, so the absolute value of a is always greater than or equal to 0. The absolute value of a equals the absolute value of -a. All right, so just to give you a quick example of that, let's say a was 5. Right, so the absolute value of 5 equals 5. Right, the absolute value of -5 also equals positive 5. All right, so if I take a number and its opposite, the positive and negative of that same number, when I take the absolute value of each one, they always give me the same result. All right, so that's what that property is saying. The next one, the absolute value of a times b equals the absolute value of a times the absolute value of b. All right, so what this is saying is that basically if I have two numbers multiplied inside the absolute value, I can split those apart into different absolute values, or if I have the absolute value of two quantities multiplied together, I can combine those into a single absolute value. Right, which that one and the next one down here, these two kind of go together. This one is multiplication, this one's division. The absolute value of a divided by b equals the absolute value of a divided by the absolute value of b. Right, so we can split apart absolute values when we have multiplication or division on the inside, or if I have two absolute values being multiplied or two absolute values being divided, I can combine those together into a single absolute value expression. Right, which sometimes comes in handy when you're trying to simplify expressions or solve equations or things like that. And we'll see that there are some other things that come up later on, exponents, radicals, and roots, and things like that, and some other things as well, where similar rules also apply. All right, so an example of this, like let's say I had the absolute value of -3 times 5. right? Well, that's the absolute value of negative 3 times 5 is negative 15, and the absolute value of negative 15 is positive 15, all right? Well, what if I split those apart? What if I did the absolute value of negative 3 times the absolute value of 5, and did the absolute value of each one individually, and then multiplied them together? Well, the absolute value of negative 3 is 3, the absolute value of 5 is 5, and 3 times 5 is 3 times 5 is 15. And so, whether we multiply those two together first and then take the absolute value, or we take the absolute value of each individual number and then multiply them, either way, it's always going to give us the same result. It doesn't matter if these numbers are both positive, both negative, or one of each like we had here, right? So that's going to be true of multiplication and also for division. Right? If you want to try it out for yourself, just like throw a couple of numbers in for A and B and just double check that when you do it both ways, you get the same result. I'll leave that up to you if you want to try that. Right, just like we did here with the multiplication. All right, so when we're multiplying or dividing those numbers in the square root, I'm sorry, not in the square root, in the absolute values, we can split them apart, or we can bring separate ones together with multiplication or division. That does not work, though, with addition or subtraction. Right? The absolute value of A plus B is not equal to the absolute value of A plus the absolute value of B. The absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. Sometimes they're equal, but not always. Right? And again, this is another thing that we'll see as we go on and talk about other types of mathematical expressions and functions and stuff. You know, there are certain rules for multiplication and division. Those rules don't always apply for addition and subtraction. Right, here is one example of that. Right, so the absolute value of A plus B, let's do a couple examples of this. Right, so let's say we had absolute value of 3 plus 5. Well, that's the absolute value of 8, which equals 8. Right, what if I split those apart? What if I did the absolute value of 3 plus the absolute value of 5? Well, the absolute value of 3 is 3, the absolute value of 5 is 5, and 3 plus 5 equals 8. So we see here, well, if both of those numbers are positive, right, positive 3 and positive 5, the absolute value of 3 plus 5 equals the absolute value of 3 plus the absolute value of 5, so this should be an equal sign here. Why does it say less than or equal to? Well, what if one of those numbers is not positive? What if we had the absolute value of negative 3 plus 5? Well, what's negative 3 plus 5? That's 2. Right, so this gives us the absolute value of 2, which is going to equal 2. What if I split those apart? What if I did the absolute value of negative 3 plus the absolute value of 5? The absolute value of negative 3 is 3. The absolute value of 5 is 5. 3 plus 5 equals 8. Those are not the same thing. Right? So sometimes this works and they are equal to each other. The only time that's going to work, though, is when these two are both positive, or if they're both negative. If we have two negative numbers there, that would also work out and they would equal the same thing. But if one of these numbers, A or B, is positive and the other one is negative, we can see, adding them together first and taking the absolute value, we actually get a number that's less than if we take the absolute value of each number individually and then add them together. Right, so that's why this is not an equality here, it's an inequality, because this is not always true. They're not always going to be equal to each other. And like I said, it's something that comes up in a lot of other contexts as well in mathematics, especially as you're doing algebra and like higher levels of algebra. There are some rules for multiplication and division. The rules are different for addition and subtraction, right? They don't always correspond to each other. And we actually saw some of that with fractions when we were talking about simplifying fractions. You know, if I have fractions where I have multiplication in the numerator and denominator, I can simplify. If I have addition or subtraction in the numerator or denominator, I can't simplify, right? I can't like cancel stuff out, right? So here's another example of that. And it's something you have to be very aware of when you are working in any type of mathematical problem. What rules apply, what rules don't apply. All right, again, multiplication and division, different rules usually than addition and subtraction. You got to be really careful. All right, I'm going to pause this here, and then I'll put up a couple examples of doing some absolute value problems, and that'll be it for this. All right, last thing here about absolute value, just a few quick examples. And I put back up here the definition of absolute value that we saw a little while ago. All right, the absolute value of A is equal to A if A is greater than or equal to 0. It's equal to negative A if A is less than 0. Right, so which one of those two definitions we use depends on what we have inside that absolute value symbol and whether it's positive or negative, whether it's greater than or less than 0. Right, so for the first one, A here, the absolute value of 3. Well, 3 is greater than or equal to 0, right? 3 is bigger than 0, so we're using that first definition. So the absolute value of 3 equals 3, right? That first definition says if whatever's inside that absolute value is bigger than 0, which 3 is, then the absolute value just equals that number that's on the inside, 3. All right, example B, the absolute value of 0. Well, which one of these two definitions does 0 fit into? Well, 0 is greater than or equal to 0, right? This is the one that is equal to 0, so we use this definition, which means it's the same number, so the absolute value of 0 equals 0. Right? And if you think about it in terms of what the other definition we saw before, the distance from 0 on the number line, 0 is 0 units from 0. Right? To get from 0 to 0 on the number line, I don't have to travel anywhere at all, so the absolute value of 0 just equals 0. Right? The absolute value of -3. All right, well, -3 is less than 0. Right? So now I have to use this second definition of the absolute value, or this second branch of the definition for absolute value, right? Which says the absolute value of a equals -a if a is less than 0. So it's negative of -3, right? But when I have that double negative there, that makes it a positive, so the absolute value of -3 equals +3, like we saw before in one of those examples a few minutes ago, all right? And like we also saw in one of those properties, the absolute value of 3 and the absolute value of -3 equal the same number. Right? When I have the positive and negative of the same number, the absolute values make them equal. Right? The last one on here, the absolute value of 3 minus pi. This one's the trickiest one out of all. All right, the question is 3 minus pi positive or negative? Right? Because remember, since we have subtraction here, I can't like split this apart. Right? This is not the same as just doing the absolute value of 3 minus the absolute value of pi. Right? That's not correct. Remember, I can only split that apart if what's inside here is multiplication or division. If there's addition or subtraction, I can't just split it up into separate absolute values. Right? It doesn't. Sometimes that'll work out, but not always. And when you're starting a problem, you don't know whether it's going to work out or not, so you can't just assume that it's going to. Right? So the absolute value of 3 minus pi. So I have to use my definition. Is what's inside that absolute value greater than 0 or less than 0? Right, so that's what we have to decide. 3 minus pi. Which one of these two things is it? Greater than 0 or less than 0? Well, think about what pi is equal to, right? Most people know that pi is approximately 3.14. So if I do 3 minus 3.14, would that give me a positive or a negative value? Well, 3.14 is bigger than 3. So if I do 3 minus 3.14, I'm going to get a negative result. It's going to be less than 0. Right, so 3 minus pi is going to be less than 0, which means we have to use this second branch of the definition of absolute value. All right, so 3 minus 3.14, I get less than 0, which means the absolute value of 3 minus pi is the negative of 3 minus pi. Right, just following the definition, it says if a is less than 0, which we determine that it is, the absolute value of a is negative a. So whatever is inside that absolute value, I have to take the negative of that quantity. Right? So it's the negative of 3 minus pi. Right? Now remember, 3 minus pi is an entire quantity here, so I have to put that whole thing in parentheses and the negative outside of that whole thing. Right? And like we saw previously in one of the videos I did before, if I have a negative outside the parentheses, I distribute that to everything inside, which would give me a -3 and then plus pi. Or pi minus 3, if I rearrange that and put the pi in front and then the minus 3 second. So the absolute value of 3 minus pi is pi minus 3. Right, think about it like this. 3 minus 3.14, that's negative 0.14, right, which is less than 0. So the absolute value of that would be positive 0.14, which is what pi minus 3 would give you. 3.14 minus 3 gives you positive 0.14. Right, but we want to give it as the exact value, which is that pi minus 3 there. All right, so that's about as tricky as absolute value gets, something like that. For absolute value of just a single number, it's not that hard. If that number is positive or 0, the absolute value is the same thing. If that number is negative, the absolute value just makes that number positive. All right, when you get stuff like this, you have to actually think about it a little bit and determine which part of that definition you need to use. All right, so that's all the stuff we have here about absolute value.